my name is Emine Fadan. I'm a PhD student at NC State University, and today we'll be talking about how we can use the open source software R to create interactive maps, and these videos will be serving as an introduction. So these are the different topics that we'll go over, and the first thing we'll talk about is just an introduction of some GIS fundamentals. So you might be wondering, what is GIS? This is the definition of GIS by ESRI, the Environmental Systems Research Institute. You've probably heard of ESRI without even realizing it. For example, the ArcGIS software is a product produced from ESRI. So what is a GIS? Well, ESRI defines it as a framework for gathering, managing, analyzing, organizing, communicating, and understanding the signs of our world. GIS stands for Geographic Information System, where the geographic part refers to spatial data, and the information system part refers to a software that can edit, analyze, and display this geospatial data. So basically, GIS is a system that lets you mess around with spatial data. You can kind of think of it as a software that lets you create your own custom maps and analyze the spatial data you're working with. There's so many things you can do with GIS software, and if you're interested in diving deeper, then feel free to reach out. These are just some of the things you can accomplish with GIS. GIS can also answer a lot of questions, like first and foremost, location. It can answer condition of that particular location or some features at that location, trends and patterns in our data. We can even make predictions using geospatial modeling. So there's a lot that we can do with GIS and GIS data. And so there's probably a lot of GIS products and GIS data around you that you've never even really considered or realized. For example, hiking maps and trails are a good example of a GIS product. These are visualizations of geospatial data produced for hiking and just maps for hiking and trails. There's also satellite imagery as well. If you've ever gone on Google Maps or try to find your address on Google Earth, that is a good example of a GIS product. There's also elevation models. So if you've ever looked at a topographic map, that is a really, really good example of a GIS product, and it displays elevation GIS data. Also field surveys. If you've ever gone out in the field and collected data, that is a really good example of some GIS data because you're collecting data at a particular location, and the data you're collecting is a particular feature. Thus, you have a GIS product there in itself. So when we're looking at geospatial data, it all contains two elements of information. So first, you have location information, right? This is what makes our data geospatial. The next is attribute information. So this tells you information about what's happening at your location. For example, if we had a map of mailboxes in your neighborhood, then the points would be the location of the mailboxes, and the attribute would be the mailboxes in itself. Now, this might sound a little bit confusing, but think about it this way. If you didn't have an attribute, then your data would just be a map of random points, right? So the fact that each point is a mailbox and those mailboxes are the attribute gives us what information we're actually collecting and displaying. So each location information that we have also has a respective attribute information with it too, right? Because we want to create a map displaying some sort of information apart from just location. So that information is called an attribute, and it can be either qualitative or quantitative. That information could either be a city name, it could be population, or it could be the color of a mailbox, right? So there's also two types of spatial data as well. So we'll go into this in a little bit more detail later on, but just as an introduction for the time being, there's two types of spatial data. There's vector data, which is in the form of points, lines, and polygons, as shown here. Then there's raster data, which is in the form of grids, cells, and pixels. So here, rasters are consisted of pixels, but sometimes they can be called grids or cells. They all mean the same thing here. Another thing is considering a map. We need to understand that what we see as one whole map actually consists of many layers of spatial data. So this might be a little bit confusing to understand, but hopefully this image will help a little bit with visualizing what I'm trying to explain. So we might have a map like this, some sort of a GIS product in the form of a map. But to get this map, we actually have to combine a bunch of data together. We need to add different spatial data together to create something like this, right? Because this data consists of trees and forested areas and buildings and, streets and roads. And so to create something like this, we need to incorporate other spatial data. And those other spatial data are in the form of vector and raster data, and they're called layers. So to create this map, we have to add a layer of vegetation data, a layer of building data, and a layer of street data. So once we combine these different layers, we actually get this whole map in itself, but we need to have these different spatial layers in order to do something like that. Here's another visualization that kind of explains this point. So again, to create this map here, we need to incorporate different spatial data layers. So we have here a raster layer because it has these different pixels, as you can see. And this incorporates our land use and land cover data set. We have another layer here that's a raster data type, again, because there's these pixels. And this is our elevation data. Maybe the black pixels represent higher elevation and the lighter colored pixels represent low elevation. We also have here parcels, so parcels of land in the form of polygons. So this is a vector layer. We also have street here, which are in the form of lines. So this is a good example of a vector data type as well. There's also a customers layer. And this spatial data type, again, is a vector because the customers represent people as points. So these points are a vector data type here. And so once we combine all this together, we might be able to produce a map sort of like this. But in order to create something like this, we need to bring in these different spatial data layers, again, which can be in the format of a vector data type or a raster data type. Next, we'll be talking about GIS software. So there's a number of different GIS softwares out there. ArcGIS, QGIS, GRASS, and ERDAS Imagine are just a few to name. These are very popular. However, there's pros and cons to each of them. ArcGIS, for example, is probably the top most popular software out there, but it is also expensive. QGIS is open source, so it's free, and it's pretty user-friendly. However, it's not as nice as ArcGIS. There are some issues associated with QGIS as well. ArcGIS is a little bit more user-friendly. So as you can see, there's pros and cons to each and every one of them, but here we'll be using R as our GIS software. And the reason for that is because coding in R allows us to create maps that are reproducible. When we create maps in these types of software, such as ArcGIS or QGIS, if we wanted to change one little thing, or if we found out that our data was missing something, recreating that map is going to take a lot of time. Whereas if we were to use code to create maps, it could just be a simple one-line change and we could recreate our map very easily. So it allows our maps to be reproducible. You can also integrate it with other apps and websites as well. So creating interactive maps in R lends itself to be very versatile. It's also open source, so it's free. So those are just some of the reasons why I'll be using R in this case. Lastly, I'll just touch on some geospatial databases. So when I say geospatial databases, I'm referring to these websites which we can download and gather geospatial data from. So data.gov is a very good resource where you can find some geospatial data. I think my favorite, though, is this Data Gateway by the NRCS and USDA. This is a great resource here where you can download geospatial data. It could be for a county or it could be for a state. There's lots of different geospatial data you can pick from, ranging from streets to counties and watersheds. So there's a lot of different geospatial data that you can find on this website. If you're looking for some geospatial data for Puerto Rico, this website also offers some great geospatial data that you can download as well.